Okay, 4.1 deals with congruence and transformations. Our objectives in this lesson are to draw, identify, and describe transformations in the coordinate plane and use properties of rigid motions to determine whether figures are congruent and to prove figures are congruent. So we have three types of transformations: reflection, which is a flip across a line. Each point and its image are the same distance from the line of reflection. So the first one is a reflection, which is just a flip across the line. A rotation is a transformation about a point P called the center of rotation. Each point and its image are the same distance from P. So a rotation is just a turn. So you either rotate clockwise, which would be to the right, or you rotate counterclockwise, which would be to the left. Then we have translation, which is a slide, and it is a transformation in which all the points of a figure move the same distance in the same direction. So it's just the same shape sliding in one direction or another. So again, we have the translation, which is a slide. And here we have points x and y. And when we add a to x, it shows us that the translation's moving horizontally. So if a is positive, it's going to go to the right. If it's negative, it's going to go to the left. And when we add b to y, it's going to move vertically. So if we add a positive number to y, the shape's going to go up. And if we add a negative number, the shape's going to go down. Reflection is a flip. So we can either make x negative, which would reflect it across the y-axis, or we could make y negative, and it's a reflection across the x-axis. And then we have rotation, which is a turn. So when we rotate 90 degrees clockwise, we flip the x and y, so the x and y are changing positions, and we make x negative. When we rotate counterclockwise, we change the x and y, but y is negative. And then when we rotate 180 degrees, we just leave them in the same, so it'll be x and y, but they're both going to be negative. And then dilation is when you multiply a number by the x and y, and that number that you're multiplying is called the scale factor. We're going to go over lots of examples. So apply the transformation M to the polygon with the given vertices. Identify and describe the transformation. So in this example, M is telling us that we subtract 4 from x and we add 1 to y. So we're going from P, and our transformation will be P prime. That's what we'll call our new P. So we're going to do 1 minus 4, and then 3 plus 1. And we're going to get negative 3. 4 is going to be our new point. We're going to do the same thing for Q and call it Q prime. So we're going to subtract 4 from 1, and we're going to add 1 to 1. So our new point is going to be negative 3, comma 2. And then we're going to do the same thing to R and call it R prime. And we're going to subtract 4 from 4 and add 1 to 1.
Where do you get the word prime from?
Just, that's what we're calling our new point, as just like P with a little tick mark.
Just to show it's not the same as the
Right. So we have 0, comma 2. So in this transformation, we're sliding it to the left 4 and up 1. So x minus 4 is telling us that it's going to the left 4, and y plus 1 is telling us that it's going up 1. So when we're sliding something, what type of transformation is it? If you go back to the page before. Translation. Perfect. So this is a translation. 4 units left. And 1 unit up. Let's look at the next example. So here we're going to leave x the same, and we're going to make y negative. So a prime is going to be 1, comma, negative 2. B prime will be 4, comma, negative 2. And C prime will be 3, comma, negative 1. So we left all of our a coordinates the same, all of our x coordinates the same, and we made all of our y coordinates negative. So if we plot all of these points, what are we doing to this shape?
Reflection.
Reflection. So it's being flipped across the x-axis, so this would be reflection. Yep. So it's a reflection across the x-axis. Bathroom. Next example. So we're going to flip the x and y is going to go first, and we're going to make x negative. So this is going to, r prime will be 0, comma 3. Allie, what will e prime be?
E would be 3, 3.
3, 3, perfect. Gabby, what do you get for c prime? What? So we're changing this, we're flipping the x and y, and we're making the x negative. Joseph, what do we get?
3, 1.
3, 1, perfect. And Jeremiah, what do we get for t prime? 0, 1. Awesome. So we're going from this blue box, and now our new shape is the red box. What are we doing? Rotation.
Is it rotation because you flipped it across the y-axis?
It's rotation because we're turning it. So this is going to be a rotation 90 degrees clockwise.
Is it always 90 degrees? Like,
Unless it's 180 degrees. So it's either going to be 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees, and it'll go like a semicircle around.
for dilation, I don't understand what 0, 0 has to do. The point. Is that just the origin?
Yeah.
Oh, okay.
So dilation, the important thing here is the scale factor, k, is what's going to be multiplied to the x and to the y.
Can k be anything in this problem?
It can be anything. It just has to be greater than 0. So here we're multiplying 3 times x and times y. So now we're going to have k prime. Kennedy, what's our k prime going to be? -6, -3. Kevin, what's our L prime going to be?
It would be 3, -3.
3, -3. And Sydney, what's our N prime going to be?
2, 1, -1.
So we're multiplying 3 by 1 and we're multiplying 3 by -2. We are on D on the 8th page. 3, -6. So if we look at this picture, this is our original, the blue triangle, and it's being stretched to look like the red triangle now. So this is dilation. And what's our scale factor?
3.
Our scale factor is 3.
Oh. Do we have to do it, well, in the future, will we have to put the scale factor?
Yes. So apply the transformation M is xy to 3x, 3y to the polygon with vertices B, E, and F, and name the coordinates of the image points. Identify and describe the transformation. So right off the bat, what type of transformation do we know this is when we see that 3 is being multiplied to x and 3 is being multiplied to y?
Dilation.
Dilation. And what's our scale factor?
3. That's all we had to do.
Well, now we have to come up with the new points because it says name the coordinates of the image and describe the transformation. So we just described the transformation without even having to do anything. We just looked at it. And now we need D prime, E prime, and F prime. So what's our new D going to be? Ethan. Three, 9. Perfect. What's our new E going to be, Mariana? Three, -6. And what's our new F going to be, Ryan? Nine, comma, 0. That's all we got to do. So translations, reflections, and rotations produce images that are congruent to their pre-images. So when a transformation is a translation, reflection, or a rotation, the images are going to be congruent. When it's a dilation, they are not congruent. So determine whether the polygons with the given vertices are congruent. So our first points, A, B, and C, are going to be our x, y, and we need to figure out what we're doing to the x's and to the y's. So how do we get from -3 to -4? What can we do to -3 to make it -4?
You add up by negative.
So we subtract 1. Let's test it out on the next one. If we subtract 1 from 2, do we get 1? Yes. So that works. And if we subtract 1 from 1,
0.
we get 0. So for our x, it's going to be x minus 1. And let's look at the second, our y. So what do we do from 1 to get -2?
Minus.
We minus 3. Let's see if that works on the next one. If we minus 3 from 3, do we get 0?
Yes.
And if we minus 3 from 1, do we get -2?
Yes.
So the next one will be y minus 3. So just looking at the transformation here, what type of transformation do you think this is going to be? So if we subtract 1 from x, that means we're going to the left 1, and then we're going to go down 3. If you look at the picture, we're just sliding this way. So what is it called when we just slide? Translation. So this is a translation. And we're moving to the left 1. And we're moving down how many? 3, because it's y minus 3. So we're moving down 3 units. Are these two shapes congruent?
Yes, because it equals like A equals 1.
Yes, they're congruent because we said translations are congruent. We're taking the same shape and just sliding it somewhere else. It's in a different location, but it's the same shape. So they are congruent shapes. Yeah. Let's look at the next one. Just by looking at the picture, what do you think is happening here? Dilation, because it's obviously getting bigger, and the only one that the shape changes are dilation. So we're going to have to multiply something to our x and y to get our new x and y. So what do we multiply by 2 to get to 3? If we're multiplying something by 2 to get it equal to 3, what does x have to equal? 1.5. So our scale factor for x is 1.5. Let's see if that works for the next one. What's 1.5 times 4?
6.
And the next one, what's 1.5 times 4? 6. Perfect. Let's see if it works for y. What's 1.5 times -2? -3. What's 1.5 times -2? -3. And what's 1.5 times -4? -6. So our y is going to be 1.5y. So what type of transformation is this? Dilation. And what's our scale factor?
1.5.
And are these two shapes congruent?
No. Is that right?
Mm-hmm. Okay, let's look at the next one. Determine whether the polygons with the given vertices are congruent. Support your answer by describing a transformation. So we're going from triangle ABC to triangle PQR. So we're going to start with A.
It's rotation.
Allie, you're too fast. Then B. And C. And we're going to go to P, Q, and R. So just looking at A and P, how do we go from A to P? What do we need to do to our X and Y?
We switch.
Well, so from X, if we subtract 1, we get 1, that's right. But if we look at the next point, if we subtract 1 from 3, so it doesn't work there. Allie, what'd you say?
You switch them.
We switch them. So we make the X our new Y, and we make the Y our new X. But -1 isn't the same as 1, so what do we have to do to the Y?
You have to make it negative.
We have to make it negative. Let's see if that works so we have our Y, negative Y, and our X. So let's see if it works for the next one. Can we just switch these and make the Y negative? Yeah, because -0 is 0. For the next one, we can switch them and make the 3 negative. So that's perfect. That works. So when we go from XY to -YX, what type of transformation are we doing? Rotation. And when we rotate one of our shapes, are they going to be congruent? Yes. So when it's a rotation, the shapes are congruent.
Because it's just the same shape.
Because it's the same shape, we're just rotating it. Helpful hint. Translations, reflections, and rotations can be called congruence transformations. So translations, reflections, and rotations are the only ones that are congruent. The one that's not congruent is dilation. So dilation is not congruent. So out of the 4 transformations that we have, the only one that's not congruent is dilation. So apply the transformation M to the polygon with the given vertices. Identify and describe the transformation. So when we apply M, we're going to have which we're multiplying 3 by the x and y, so what do we get for A prime?
0, 3.
0, 3. What do we get for B prime?
6, 3.
6, 3. And what do we get for C prime?
6, negative 3.
6, -3. When we're multiplying something by the x and y, what type of transformation is it?
Dilation.
Dilation.
And the scale factor is 3.
And the scale factor is 3. So apply the transformation M to the polygon with the given vertices. We're doing the same thing. A prime, which we're going to switch the x and the y and make the y negative. So what would A prime be?
Negative 3, 0.
-3, 0. What's B prime going to be?
Negative 2, 1.
-2, 1. And what's C going to be?
Negative 5, 4.
-5, 4.
Rotation.
and it's a rotation. And since the y is negative, it's going to be a rotation clockwise. So it's 90 degrees clockwise. Okay, so in this one, we're going to add 1 to x and subtract 2 to y. So what's our a prime going to be?
-1.
Negative 1,
And
Negative 1.
negative 1. What's our b prime going to be?
Negative 3, 2.
When we add 1 to negative 2, what do we get?
Add 1.
Negative 1, and we subtract 2 from 4. What do we get? 2. And what's our c prime?
1.
1, 1. So when we're adding to the x and subtracting from the y, what type of transformation is this? Translation. Because we're just sliding the shape. So what direction are we sliding the shape?
Right.
1 unit.
One
Right.
unit to the right.
2 down.
1 unit right
2 units down.
and 2 units down. Determine whether the triangles are congruent. So we have triangle ABC and JKL. So from A, we have 1, 1, and we're going to J, which is 2, 2. From B, we're going to 1, negative 2, and K is 2, negative 4, and C is 3, 0, and L is 6, 0. So what are we doing to the x and y over here to get the ones over here?
No, you multiply by 2.
We're multiplying by 2. So we're going to go from x, y to 2x, 2y. So what type of transformation is this? Dilation. And what's our scale factor?
2.
2. Are these shapes congruent? ABC and JKL.
No.
No, they're not. So these are not congruent. That's everything for 4.1.